Okay, so today we are going to cover stoichiometry and kind of what that means, and it's also going to involve some practice calculations. So to start, our learning target today, we're going to use stoichiometry to calculate the amount of a substance produced in a chemical reaction. So we're going to take into account how we've been able to convert between moles and grams. We're going to take into account our balanced equations today, and we're going to actually start using them to solve for some of these products in a chemical reaction. So the first thing we're going to do is watch this little video, and while we do that, you're going to complete basically like this first page, questions 1 through 5 of your notes page. Okay, and the video does go a little bit fast, so you may have to pause and, or replay, back it up a little bit to get the answers. But basically, we're going to kind of see the premise of the video is talking about how to make a grilled cheese sandwich. So, you can start, if we know we need 2 pieces of bread and 1 piece of cheese to make a grilled cheese sandwich. And so we're going to start talking about like, okay, well, if I want to make 10 grilled cheeses, how much bread and how much cheese am I going to need to make those things? Okay. So like I said, watch the video. I'm going to play it here. And then as it's playing, you're copying your notes. Okay. So make sure that you're okay, sorry, I just want to make sure it's actually still recording. Make sure you're writing down as this is playing, okay?
Welcome to Stoichiometry Made Easy with Ket's book. In this video, we're going to learn what is stoichiometry and how to solve one-step stoichiometry problems. But before we begin, let's start with a question. Which of the following always contains the same number of atoms? 1 gram of atoms, 1 mole of atoms, or 1 liter of atoms? The correct answer is B, 1 mole of atoms, which is equal to 600 billion trillion atoms. Remember that just like a dozen is 12 things, a mole is simply a very large number of things. And because the mole refers to the number of things, we will need to use the mole extensively when we do stoichiometry. So, what in the world is stoichiometry? The word comes from 2 Greek roots, stoichion, which means element, and metron, which means measure. Basically, stoichiometry is a scientist's way of measuring elements and other chemicals in a chemical reaction. It's a lot like the way a chef measures the ingredients of a recipe. In fact, chemistry is a lot like cooking. Imagine for a second that you're home alone and craving some grilled cheese sandwiches, but you don't know how to make one. So you call up your friend and say, "Hey man, how do you make a grilled cheese sandwich?" And he says, "Dude, chill. It's real easy. Just take some bread, put some cheese in the middle, heat it up, and you got yourself some grilled cheese." How much bread? How much cheese, you ask? 2 slices of bread and 1 slice of cheese is all you need to make one sandwich. So there you go. You've got your recipe. In chemistry, the recipe is the balanced chemical equation. So where does stoichiometry come in? Let's suppose you are super hungry and you want to make 7 grilled cheese sandwiches. You need to know how much of each ingredient to use. Let's start with the first ingredient. How many slices of bread do you need to make 7 grilled cheese sandwiches? You can probably solve this in your head, but please follow the logic of my method. In order to solve this problem, we are first going to write down the quantity that we know, 7 grilled cheese sandwiches. Next, we are going to multiply this by the ratio of bread to sandwiches. You need 2 slices of bread to make 1 sandwich. Where did I get those numbers? The recipe, or the balance equation, tells us the ratio of the ingredients and products. Bread and sandwiches are in a 2-to-1 ratio. We put the 2 slices of bread on top because that is what we are solving for, and the 1 sandwich on the bottom because that is the quantity that we started with. Sandwiches on the top and bottom cancel each other out, and we are left with 7 times 2 slices of bread to make 14 slices of bread, which is our final answer.
I'm going to pause it here for just a second. If you need to back it up, make sure you should have everything answered all the way through like A, B, C, D in the box. Okay, so if you need to go back here, rewind and play it again to make sure you've got all those questions. because next he's going to look at a real equation, and he's going to do basically the same thing he's been doing with grilled cheeses, but we're going to do a real equation with making ammonia.
Notice that this is really a unit conversion problem, and the balance equation is our conversion factor. Okay, now we're going to do the exact same thing with chemicals that we just did with food. Check out this reaction. Nitrogen reacts with hydrogen to produce NH3, which is called ammonia. This reaction is known as the Haber process, which is primarily used to make fertilizer. Fertilizer helps crops grow and becomes part of our food. In fact, more than half of the nitrogen in your body probably comes from this reaction, so it's pretty important. As it's written, the reaction is not balanced. There are 2 nitrogens on the left and only 1 on the right, so we put a 2 in front of ammonia to balance the nitrogens. This gives us 6 hydrogens on the right side, but only 2 on the left, so we put a 3 in front of hydrogen. Now the reaction is all balanced. Remember, our balanced reaction is a recipe, so what is it actually telling us? The balanced chemical equation tells us that 1 nitrogen molecule reacts with 3 hydrogen molecules to make 2 ammonia molecules. Well, what if we have more? Let's say we have 10 nitrogen molecules. How many hydrogen molecules would they react with? That's right, 30, and the reaction would produce 20 ammonia molecules. The balanced chemical equation tells us that nitrogen, hydrogen, and ammonia are always in a 1 to 3 to 2 ratio, no matter how big or small the reaction is. So, let's talk about a large amount of nitrogen. The air you breathe in every minute when you are walking contains approximately 600 billion trillion nitrogen molecules, which is equal to 6 times 10 to the 23rd. Does that number look familiar? Yes, we're talking about 1 mole of nitrogen, and 1 mole of nitrogen will react with 3 moles of hydrogen to make 2 moles of ammonia. Where am I getting those numbers? They are the big numbers in front of the chemicals in the balanced reaction. Let's try a sample problem. How many moles of nitrogen do you need to make 10 moles of ammonia? First, write down the quantity that you know, 10 moles of ammonia. Next, multiply that by the ratio of nitrogen to ammonia in the balanced reaction. Since we are starting the problem with ammonia, we put the 2 NH3 on the bottom. This 2 NH3 comes directly from the balanced reaction. Because we are solving for nitrogen, we put 1 N2 on the top. That 1 N2 also comes from the balanced reaction. Remember, if no number is written in front of a chemical, that means the coefficient is 1. Last of all, do the fraction multiplication. 10 times a half is equal to 5. As for the units, notice that the ammonia we started with cancels out with the ammonia on the bottom of the fraction, and we are left with moles of nitrogen, which is exactly what we want. Let's try one more problem. How many moles of ammonia can you make from 0.37 moles of hydrogen?
All right, so that gets you to the bottom of your notes, okay? So this is kind of the first thing, right? The way that he got 14, just to make sure we're all on the same page. You probably did this in your head, but remember, we did the same thing we've been doing with our grams and moles, right? Whatever unit you have on the top, you want to make sure you have on the bottom. That way it can cancel out. Okay, and all we're saying, where we're getting these numbers is we're just taking our coefficients of our balanced equation. So remember, there's an invisible 1 right there in front of my grilled cheese. So we're saying for every 1 grilled cheese, we have 2 pieces of bread. Okay, so that's how he solved this one. Same thing here, right? I need my coefficients. I know NH3 is going to go on the bottom because NH3 is on the top, and I want them to cancel. What number is in front of NH3? A 2. Since I'm looking for N2, I want N2 on the top. What number is in front of N2? An invisible 1. Okay, so we end up with 5 moles of N2. So what this is saying is it's saying if I want to produce 10 moles of ammonia, like I'm in the lab and I want to produce 10 moles of ammonia, in order to do that, I have to have at least 5 moles of N2, of nitrogen, to do that. If I don't have 5 moles, if I have 4 moles, I'm not going to make ammonia at all. My reaction is not going to do anything. Okay, so that's how we're using these ratios. They're just conversion factors. It just allows us to basically jump from one side of the equation to the other. Okay. So what is stoichiometry? This is the next page of your notes. And I think it's actually, yeah, what do we need to do? What is stoichiometry? I don't think you actually have to write this part down, but I'm just, the word, where it comes from, stoichion means element, metro means measure. So we're just measuring the amounts of elements is all that really means. And like the video said, it's just a way that we can kind of take like ingredients of a recipe. If you want to make one cake, you might need 2 cups of flour, right? If you don't have 2 cups of flour, your cake is not going to turn out right. So that's all that we're doing here with stoichiometry. We're trying to figure out how much we need in order to make a certain amount. So here's where I think your notes pick up. Notes, stoic, can't even speak. So your notes, what do we need in order to perform a balance or perform stoichiometry? We have to have a balanced equation. We have to know what we're given, just like any type of conversion problem. And we have to know what we're looking for. Okay, so the last two are the same as what we've been doing. We know what we're given. We know what we're looking for. All we're factoring in now is this balanced equation here. Okay, that's only a new part that we're doing. I'm going to stop here with this video. The practice problems will be in the part 2